someone, maybe someone who doesn't usually speak, explain what regular expressions are to someone who's never seen them. Okay, how about anyone? I made that too restrictive.
They're matching patterns in the strings.
Okay, yeah, so regex works on strings and it looks for patterns. Yeah. So why not just use, so if, if I have a file and I'm looking for, I want to find all my print statements. So I just do Command F or whatever and type in print.
Because you end up having different examples that you want to be able to, so like if you want to find social security numbers or phone numbers or a domain name, like string of characters with a period and then a 3-character .com or .biz, it's hard to, you have to write out all the search if you want to do it like on a string by string example, versus with regex you can identify that pattern like Cindy explained, and that way you can use it more broadly.
Yeah, exactly. So it's a way of having a general, it's a way of having a general way of searching for patterns in strings. So not just, it can be a literal match, right? You can look for a specific exact string. We can also look for a lot more complex general patterns, like a social security number. Like I can't imagine how I would do that just with Control F or whatever. How would I look for a social security number? All right, so let's just start going through some examples. So I don't want to talk too much about regular expressions in general, because it's, so I guess let me preface this by saying that you don't need to become a master of regular expressions or anything. It's kind of like CSS. It can get very complicated. You can really get in the weeds, but it's not too difficult to understand the very basics. So that's what we're concerned about here. So here is there are a number of these kinds of things. It's like nice interfaces for, I can put some example text here, and then I can write a regular expression, then I can test it and see if it matches. So this one is regexr.com. There are a few other similar kinds of ones. Okay, so let's say I have a text. So I have a text. Right, so I have apple oranges as my text, and I want to see if this text, which could be, have thousands of lines or whatever, has the word apple in it. So one thing I do is I can do a search for apple, and I get this information indicating that this is a hit. So I've matched apple, and that's fine sometimes. So at the most kind of fundamental level, regular expressions can be used to match literal characters. So when the regex engine works, it's going to first look at the first character and say, okay, is this? If it is, it'll keep moving on, basically. So it'll go character by character and look at things. It can also backtrack and do other stuff. But so this is literally going to look for the character A, followed by the character P, followed by the character P, and so on. Other things like spaces will also work as literal spaces. So there's a one-to-one correspondence between a space here and a space in my, and then I can type the rest, and that will give me an exact match. And then I don't know, right? So here's my match. Okay, so that's fine, but that's not really much different than what we're used to at a very basic level, like in a text editor or something like that. So where we really see regular expressions, shine is when we can make this a little bit more general. So one of the things that regular expressions give you is these character classes. So we have literal characters, like, I typed in APPLE, right? Those are literal characters. And we also have meta characters. So there's a whole set of these meta characters, which are basically just kind of symbols for character sets. So I can do something like, so let's say I have a number. So I can do a search for, so /D is going to be a digit. So anything that's 1 through 0, or like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I can also do a search for words, or just a general character, for example. So /W. So /W will be anything that's not white space, basically. And these character classes, I think most, maybe all of them, have opposites. So W is basically anything that's not white space. Capital W is anything that is white space. So this space right here is highlighted. And the same thing, we have D, which is a digit. We can use capital D, which is anything that isn't a digit, which includes white space and then other characters. So there are other characters, and you can look those up as you need them. But so we have literal characters, which is going to be like, the actual letter or character, or whatever. We have meta characters like /D for digits. And then we also have these things called quantifiers. So a quantifier will tell you how many things you want to find. So if I want to find a 4-digit number, I could do something like /D/D/D/D/D. And now this whole thing matches. And if I had another number here, if I had some more numbers on the end, then they're not going to match unless I get another set of 4. But right, so one way of doing this is just to repeat this meta character as many times as you want, and that works. But of course, that should make you cringe just a little bit at this point, because we're repeating ourselves. So there is another way to do this, where we can, so there are actually a number of these quantifiers. So the first one means that either you can have 0 or 1 of it. And that is a question mark. So we're looking for either 0 or 1 digits. So we get a match here. So why would you want to look for 0 digits? That kind of thing will make sense when you have larger expressions. Basically makes it optional. So if I had something like AB2, something like this, I mean, that's not a good example, but we'll see some more examples that actually make some sense. So the question mark after makes it optional. So I can also use the question mark, not just with these meta characters, but also with a literal. So I could do okay, so this matches, and if I delete the L, this also matches, because this question mark means that the preceding token, in this case an L, is optional. So whether I have it or not, it will match. Okay, so that's a question mark. We also have a plus sign. So a question mark is 0 or 1. A plus sign will be 1 or a bunch, 1 or more. So you can do. So we're looking for a digit, and we're looking for 1 or more digits. So this will 1, 2 will work. 1, 2, 3, 1, 2. I can have as many digits as I want, right? And it's going to match. That's not going to match. I have 1 digit and it starts to match. Okay, so plus sign is 1 or more. There's also an asterisk, which basically means 0 or more. So one nice thing about this particular, by the way, this particular GUI is that, you can highlight over stuff and it gives you a lot of good information. You can also look down here at the details. And it describes everything that's happening. So this is I think it's a good tool, and there are other similar tools. Okay.
Jan, I have a question. Is there some type of reference that explains all these codes that you're putting in this GUI interface?
Yeah, I mean, if you just do a search for regular expressions, there's a ton of resources. I think there's a few things linked in the curriculum as well. So we have this asterisk. We can also, so the plus sign, the asterisk, the question mark, these are kind of general. We can also be more explicit, and we can say we want exactly 3 digits. So this, whatever you put in the curly braces, so this is saying I want exactly 3 of the preceding token. So exactly 3 digits. You can also specify a range here. So let's say between 3 and 5. So that, whoops, that doesn't match. Neither does that. Okay. So that's, that right there is a general overview of the basic components of regular expressions. You can get, more complicated, obviously, but that's the basics. If you know, you can match literal characters. You have these character groups. I should mention one other thing real quick. So another thing you can do is you can have whatever is in brackets. This is like an or. Everything that's in here, it's as though it's separated by an or. So I can do. So A will match. So let's try doing digits. So we'll do a digit, and we'll do one or more digits. We use the plus sign. So one or more digits followed by an A, a B, or a C. So what's happening here? Okay, right, sorry. Okay, so we have the pattern we're looking for is one or more digits and then either an A, a B, or a C. So we can switch this to B, C, but if we go D, then that doesn't match anymore. We can also do, we can negate everything that's in here. So if you put a caret at the beginning of what's in the brackets, then now what we're saying is we want one or more digits plus anything that isn't an A, a B, or a C. So that won't work, but now we can do G and so on. Okay, are there questions about that so far? All right, so let's do a quick example. So one common, a lot of regular expressions that you use are going to be very common tasks. And you're probably going to be able to find something already made. So if you're trying to find email addresses, probably don't need to start from scratch. But let's start from scratch. So let's make something that will parse email addresses. So I have a couple emails. Let's see. Okay, so we have a bunch of emails here, and rather than searching specifically for emails, we want a pattern that will allow us to capture these. And then let's have a bad one. So we don't want to capture bad email, and we want to capture these 3 good emails. So one thing we can do is, oh, go ahead, yeah.
Oh, we were just silent, so I figured we'd jumping in. But definitely look for the @ sign, and then we could even look for mail as well.
Okay, yeah, so that's good. So what we want to do is make sure we're matching the entire email. So yeah, I think probably looking for an @ sign is good. Maybe you can use a literal character for that. So we'll literally look for the @ sign. What about what's before the @ sign?
Different length of characters.
Yeah.
A through Z characters.
Okay. So we could do, so we can actually do A through Z. We can use this set. We can do A dash Z. So we'll come back to the @ sign in a second. So one thing we could do is A through Z. Now maybe this is a valid email and our data set just isn't showing it. Just something to think about, but for now, we can ignore that. So we have a character, and then how many, I guess, so we could do this, and I could do Okay, so now we're getting somewhere. So how many characters do I need to do this again?
One or more, so maybe a plus.
Okay. So plus will match one and more. So I think that's good. Because we're probably not going to have 0 characters before the @. So probably going to want at least one. And then, we could specify an upper limit. If we wanted to do that, we could use the curly braces and say one, I don't know, you can only have up to 10 characters. But let's go with the plus sign. So we have A through Z lowercase. And by the way, this dash is a shorthand. It's a special character here. We could also just do A, B, C, D, E, F, G, and so on. We could type all these out individually.
Yeah, if you want to do uppercase and lowercase, would it be lowercase a, uppercase A, lowercase z, uppercase c?
Yeah, so you can actually do this as well. So this will be all lowercase A through Z and all uppercase A through Z. So again, this test right here, you can think of it like an OR. So either A or B or C or D or E or F or G, and it's relevant to one character. So the regular expression engine is going to look at one character and see, is this true for this one character? Is this A through Z lowercase or A through Z uppercase? Okay, so we have, let's just say any lower or uppercase, any number of lower uppercase letters, at least one. And then we have, let's do our @ Okay, so I think we're getting somewhere. It looks like we've already excluded this, at least so far. So now we have the rest of the template to figure out.
Do we want to do any number of characters again, and then a period, and then 3 characters?
Okay, let's try working up to the period. Looks like another. So again, we can do the same thing here. We can go A through Z, A through Z, and let's do a plus sign. So that works. You could also, just for the sake of variety, let's use a meta character. So we'll say anything, anything that's not a white space. So now we have the first part for the, let's say, the username. It can be any alphabet character. Then we have the @. You have to have the @ literally. Then you have to have some number of characters that aren't white space characters. And then we have a dot. Well, I'll just go ahead and put a dot here. So it looks like that will work. Okay, so we have a dot. Let's just see if we have more dots. That's strange. Does anyone have any guesses as to what's happening here?
It's a wild card character.
Yeah, so there are special characters here. In this case, the period is not, this @ is itself. It's a literal character, but the period is a special, it's a reserved character for the regular expressions. So period means match any single character. So if we want to transform this meta character into a literal character, we can escape it. We can escape it with a slash. So now this period is a literal period rather than the meta character. Okay, so now we have this period accounted for, and then we have the final thing. So this last chunk.
Chad, what's the difference between the period and the W again?
So the period will be any character. So let me just. So the period matches everything.
Even white space.
Yeah. So if you wanted, the short way to match everything would be period asterisk. So 0 or more of anything. This is kind of the most general regular expression you could write. Okay. So we're back here. We've just got this last bit to take care of. So part of how we solve this depends on what we think is our data set, like what's going to describe our data set or what our rules are. So we could assume, for example, that whatever comes after the dot, maybe it could have numbers, maybe it could have dashes, maybe it could be 30 characters, maybe it can only be 3 characters and it have to be lowercase, right? So it kind of depends on the specific problem. But let's just assume that this is all we have to worry about right now. So we need exactly, well, how would you describe this? How do you describe this pattern in general terms?
I mean, because it just has 3 letters or dot 3 letters?
Yeah, exactly. So the pattern is 3 letters. So there are a few ways we could write just give me 3 letters in regular expressions. I'll do this. So I'll use /W. I'm gonna use the meta character. And then I'm gonna use curly braces and specify exactly 3. So exactly 3 non-white space characters. So if I added something else here, now this doesn't match. It doesn't completely match. So bad email doesn't match and the good emails match. So I think this regular expression, sorry. So I think this regular expression describes our data set, at least well enough. Now, this isn't the only regular expression that describes this data set, but it's one of them. Are there any questions about that so far? Okay. So I'm gonna go ahead. So we'll see this pattern happen again later, but we'll start with so regular expressions is not specific to Python or JavaScript or anything. It's a more general kind of language. I guess it's maybe not officially a computer language, but it's its own language subset, and it's found everywhere, and there are all kinds of different minor variations. But we don't have to just use regular expressions. We could use them with Python So here I have a text. So I just copied a couple paragraphs from the Wikipedia entry on regular expressions. So what I want to do is I'm going to write a Python program that will read all of this input, and then we'll look for a certain pattern. So let's do. So we haven't talked about reading or file operations with Python. So don't worry about that. This is just a freebie. So we'll see more of this later. So one thing, I'm going to need to use regular expressions. And so this is built in to the Python standard library. It's not a built-in, it's in the standard library. We have to import it. So import RE, it's the Python regular expression library. And if we want to take a look in there, here it is. So not too big, actually. Just 300, 400 lines or so. A lot of that being documentation. So if you want to, again, I wouldn't recommend, this is not like, I want to learn about regular expression, so I'm going to look here, but just, it's the code is there, so you can look at it. You can see what professional code looks like. Here are a bunch of methods. So public interface, this is the public interface. So this is, you as a user of the regular expression module, this is what will be available to you. So you have some functions called match. So one thing to notice here is that this library is a mix of functions and classes. So I'm just pointing that out. So we have match, and then match under the hood is going to call something else. It's going to call, so what is this? What's going on here with this leading underscore?
I think one means it's protected, so it's not intended to be used by the user.
Yeah. So if you preface a method or an attribute with a single underscore, it's basically, it's a conventional signal to other developers that you want this to be treated as private. That's not enforced in Python, but so I could call this function from my code here, but I shouldn't. So we have all these functions: match, full match, search, sub, and we can also go to this is the official documentation, but there's lots of other, if you just do a search for Python regular expressions, you'll find lots of things. And again, there's a list of some places to start there. But here we can see we have search, match, full match, split. So all that stuff is here. And here's the doc string describing what the method does, right? We can scroll down and we can see internals, right? So we have the public interface, which is these functions. And then we have internals, and notice starts with an underscore. This max cache starts with an underscore, and here's the compile function that all of these other public facing functions are calling under the hood. Okay, so I just want to point that out. Okay, so we want to read from this file, this text file. So there are a few ways to read from a file. Python has a keyword called with. Again, you don't need to know this right now. This is a freebie. So with is a keyword, and it basically creates a context. So you don't have to know what that means, but typically when you have a file, you have to open it, then you do some operations, and then you have to close the file. And if you don't close it at the end and there's an error, you know, if you're doing it often, then you're creating all these kind of unclosed files on your system, which can create problems. So the recommended thing to do is use this with keyword, which is will create a context, and that context has its own API, just like the Python iterable. So if you want to make something iterable in Python, you have to conform to a specific API. And if you want to make something usable with the context API here, then you have to do the same. So we're going to open a file, and we're going to import text.txt, and we'll specify, so the second parameter will be the mode. So do you want to read or write or whatever? So we'll just tell, so we want to open this file and read it. And we're going to alias this file object. You can call it whatever we want. So now I have access to this text file. So I'm going to do so these are all built-in methods. So I'm going to just to see what it looks like right here, Python. So I've just printed to the terminal all of the contents of that file. So I opened the file, and I'm reading the contents, and I just printed it. Okay. So there are a number of methods like read lines, and so on. So what I'm going to do is I'm going to create a variable contents equals text file dot read. And just because of the way regular expressions work in Python, it's easier if you're using smaller, you know, short, like single words, basically. So I'm going to do read. I'm going to split, and it'll split on spaces by default. So we could do something more elaborate if this were, you know, a real application, but this will be fine. So then I'll print the contents. So this is an array of, you know, basically every word. So I didn't even talk about what our specific goal was. So what we want to do is we want to get all of the words that are diphthongs. So all the words that have 2 consecutive vowels. So no, that's not. What can I think of? Oh, so something like that. Okay, so Harry, AI, so 2 consecutive vowels. We don't care about the sound. We just care about. So do we have 2 vowels right next to each other? So we want to get a list of all the words in this text that have 2 vowels right next to each other. So if we were going to try to solve this problem just with a normal search, so I go Control F, and then how would I even do that? It's hard to imagine how I could solve this problem without using regular expressions. So we have basically all of the individual words, and what we're going to do now is we're going to tell Python what pattern we want to use. So here is a regex pattern. So we'll have a regex pattern. So we're going to create one here. So one slight maybe slight issue is we could just use a regular string. So we could do something like, or whatever we're doing, right? but it's a better idea to use what's called a raw string. So in Python, we have formatted strings you can prefix with F. There's also raw strings. It basically just, you don't have to worry about escaping so many characters. That's the real difference. So this is going to be our actual regular expression. So let's think about, well, let's do this first. So let's just get all of the words that have vowels, which is going to be basically all of them. So we'll start off with this. So any word that matches this pattern. And so we have our pattern, and now we're going to loop through and look at examine every single word. So and then here what we're going to do is we're going to use the Python built in. So Python has a few functions, as we saw when we were looking at the source code there. There's search, there's match, there's full match. And you can take a look at these, but what you really just need to know search. So search is basically the broadest one. There's also match, which is almost the same thing, except it starts from the beginning. I'm not sure why it exists, but so search, and search will take in a pattern, and it'll take in the string that you want to search in, and then it'll take in optional flags. We haven't talked about flags yet, but if you look here, for example, in this interface, there's something called flags. And I have a couple turned on. I have the global flag and the multi-line flag. So if I turn off these flags, the global flag in particular, it's going to stop at the first match, right? So this regular expression, it's going to look through all this stuff, and as soon as it finds a match, it's going to stop. If I turn on the global flag, it's going to it's going to keep looking, basically. So flags can do a couple things. Flags can make your search case insensitive, things like that. All right. So we're going to use the built-in search. So dot search, and we're going to look for the pattern, and we're going to look inside of the string, which is going to be content. So when we run this is actually going to return, let's see if documentation says it. Yes. Okay. So here's a description of search. It scans through a string looking for the first location where the regular expression pattern produces a match and returns a corresponding match object. We'll see that in a second. Return none if no position in the string matches. So if there's no match, then this will return none. And if there is a match, it will return some kind of match object. So we can set this equal to a variable. And we can check if it's none or not. So you can do something like that, because none is falsy. So if there is an actual hit, then we'll try doing this at first. All right, so let's run this again. And it looks like we got a whole bunch of stuff, right? So this is what the match object looks like. May not be all that helpful by itself. So to actually see what got hit, you have to call this group method on the match object. And we can see what matched. And again, we're just looking for a vowel. So these are all the vowels that matched. Okay, so we have the basic structure of, again, the file stuff is just initial exposure. We're reading the file. So what we care about now is we can use a Python built-in method to basically take in a regular expression pattern and then some strings to search through. So if we use this search, and then we can get a result. So what we want to actually look for is diphthongs. Right now, we're only doing a search for one vowel. So how could we match two vowels in a row?
Brackets 2.
Okay. So we could do brackets 2. Let's see if that works. Okay, it looks like that works. So now we have all the diphthongs. We could also, not recommended, but we could also just repeat that again. Now it'll give us the same result. But this is, should
That
use
might be
this.
a way to do it if you're looking for Y.
If you're looking for like
if Y might be in the second vowel, but not the first.
Yeah. So that would definitely be, so you can really expand this and get more specific and detailed for sure. But if we assume, that we only want, that we want 2 of whatever is in here. And note that it's exactly 2, right? Not just 1. So we're not getting any of these, the single vowel. And what if we did 3? Probably won't be. So there are no instances of 3 vowels in a row.
Would you get the first 2 vowels if you had 2 in the curly braces? Would you get the first 2 of a set of 3, or to skip it because it's 3?
Sorry, could you ask that again?
So if you have 2 in the curly braces and there is a word with 3 vowels, would it give you the first 2 vowels from that word and then just skip the third?
Yeah, I believe that's what it'll do. We can check that real quick. Yeah, so it should just return those 2 that match. Okay. So right here, we're getting all the diphthongs, but we're not matching the whole word that it occurs in, right? So how could we make sure that we're matching the whole word instead of So let's just look at an example here. So this non-contrived example, leaders. So how would we describe, let's just say if we wanted to match something like this. So we have our 2 vowels in here. And it looks like it's preceded by maybe some letter or letters, and it's followed by some letter or letters.
So we want to look for 0 or more
So you'd use like
A to Z
star, right?
characters.
Sorry, Yeah, so 0 more.
A to Z characters.
Okay, so we could do A to Z, and we'll just check for caps as well.
Yeah, so we don't get like numbers and spaces and stuff like that.
Okay. So let's see what we get here. Okay, so it looks better. Still something missing, but we're getting more of the word now.
Is the plus 1 or more or 0 or more?
The plus is 1 or more.
Yeah, so
The question mark is 0 or 1.
yeah, I think we'll want a asterisk, I think.
Okay.
Yeah, that's what I was thinking, because what if the word starts with 2 consecutive vowels?
Okay. Good point. So if we start with an asterisk, I don't know if we have any examples, but let's just make up an example.
We do. There's the AU right there.
Okay, cool. Awesome. So now we're catching this, and let's see if that AU is there if we use a plus. Yeah, so that's gone. So probably what we want to do is the asterisk. All right, so now we can have a word that starts with either just 2 vowels or any number of other letters, and then 2 vowels. And presumably we can have other characters following the 2 vowels.
So the same thing, A to Z star.
All right. That looks pretty good. Not sure what's happening there. These probably are from examples or something, but so this looks pretty good. So one issue is that, testing regular expressions maybe not entirely straightforward, but I think this will do the trick for us. So if we want to find all of the diphthongs, we have any number of characters, including 0, and then 2 vowels, and then any number of characters, including 0, including no characters. Okay, so this is one example. This is going a little longer than I thought, so I'm just gonna paste this in. So this is finding. So this would be, Python not only allows you to search, but you can manipulate the text, right? So we can substitute, we can grab stuff based on regular expressions, and we can substitute it with something else, like search and replace. So what we're doing here is we're going to replace all of the vowels with X's. This is, nonsense example, but we're going to read the contents of the file. In this case, we're just going to read it as one big chunk, and then we're going to look for all of the vowels, and we're going to substitute. So we're going to look for the vowels. We're going to substitute X for every pattern match, and we're going to search through the contents of the text file. And this optional 4th parameter, so this is a built-in, like re.I. Again, if we go, you can go to the documentation and look at, there's some constants there. There's all these. So here's one. This is an alias, I, or ignore case. And it performs case insensitive matching. So here, I'm making sure that I get capital and lowercase vowels. So I could do it this way. I could also do, and that would have the same effect without the flag, you know, but this is something that's available to you. So if we print this out, we can see that we get a bunch of nonsense where all the vowels have been replaced by X's. All right. I know everyone loves Palindrome, so I did have an example that's a recursive solution to palindromes that uses regular expressions, but maybe it's already over an hour. I'm just going to show it anyway because I spent the time to make it, so now you're gonna have to sit here and look at me show it to you. But I won't, I'll just show it to you real quick. So a couple other things I wanted to mention. All right, so a more advanced feature that you don't really need to worry about, but you can if you would like, is called groups. So groups are set off by parentheses. And a group is kind of a way of just breaking off your regular expression into a chunk. So what I'm doing here is for the palindrome, I'm getting an individual word as input, and then I'm searching using groups. So what I'm doing is basically anything that isn't white space, this /W. And this /1 is a way of referring to a group. Again, this is more advanced, so don't worry about it. So this is referring to this group. So this is saying, basically, if it starts with an A, it has to end with an A. And then this regular expression in the middle is just going to be 0 or more non-white space characters. So we can see real quick. Let's print this out. Let's do. Okay, so the first iteration through this match, so this group is going to be everything that matches. So race car, it's a complete match. But I have multiple groups. So I actually have 3 different groups here. So this will be the first group, which I'm actually referring to here, and the second group and the third group. So when I do a search for the groups, this will give me all of them individually. Every group will have its own kind of separate match. So the first letter and the last letter are the same, and there's some stuff in the middle. The first and the last letter are the same. There's some stuff in the middle, and so on. And then this group 2 is the stuff in the middle. So let me, so I just want to show real quick a couple other features, again, just to introduce them. So I can see that So kayak is true. Sorry, this is not clear. So this gets false. This is false. But this one says true. And so is this one. So S race car is true, and kayaks is also true. Would anyone like to take a stab as to why that might be?
Is it because we're not specifying the end of the string?
Yeah. So in the case of kayaks, it's saying it's true because let's think about what matches. So it looks for something. So anything that isn't a word. So the first thing it's going to find is this K, right? So this K is going to be right here. And then it's going to find a whole bunch of stuff. So that could be anything. And this last one has to be the same as the first one. So it's K. And then it stops. So according to my regular expression, the word is kayak. So I'm actually, again, this is edge cases are a problem with regular expressions. So one way of dealing with that, there are two more special characters that we haven't mentioned yet. One of them, you can indicate the beginning of a line, or in this case, it's just a word. You can also indicate the end. So in this case, we want to, so for the end, use the $sign. So what we're saying is, you can start with a word, or sorry, you can start with a letter, then you have a bunch of other letters, and then you have to end with that same letter you started with. And this has to occur at the end of the word. So this $sign here means that this has to be the end of the word. So now this is false, as it should be. Okay, but we have this problem here, right? This is showing true when it's actually false. So we'll add the corresponding thing onto the beginning. So that is this little hat. So if you put a hat before something, that means the beginning of the word has to start here. And then we do our thing, and then the end of the word is here. So if I do this, so now these are all false, as they should be.
But if that hat is inside the brackets, it's negation.
Right, right. So if,
Characters.
yeah, so this is, I'm sorry to say that regex is even more confusing than the way I'm presenting it. So a lot of special characters have two meanings depending on the context. So the hat, when it's outside of brackets, when it's outside of so brackets. So this means anything, any character that isn't A or S. Right? So we have the brackets, and then we have the caret, and then these other characters. The caret outside of brackets means at the beginning of the word or sentence or whatever. Okay, so again, just take this as exposure and go ahead and work through the exercises. So that's all I got.